Yeah, let's go ahead and get started. I know people are going to continue to kind of join as we get along. So let's go ahead and get started. So again, everyone, welcome to a sort of a partnership type of webinar that we have going on here, hosted by DataStax and Ippon Technologies USA. Obviously, as you can see, titled Successful Scale-Out Data Approach for Financial Services with Apache Cassandra. With me today, we have Théo Lebrun from Ippon Technologies USA, and then Michael Waldrop from DataStax. So the agenda for today, obviously, will be a focus on transformational data within financial services. We will have specific use case examples to show such types of initiatives within fintech. Talk about legacy and mainframe issues, of course, associated, mostly associated with costs and legacy technology that are associated with that. Talk about the scale-out data approach itself, technical details around each use case presented, and of course, how to get started in these approaches if you are in these environments that maybe aren't up to scale just yet. So I will now turn it to Michael, who will get started with the talk.
Thanks, Nick. Thanks everyone for joining today. Apologize for the logistics. My internet literally died right before we started. So it's one of those days, but really happy to have you all here with us today. Really, we wanted to talk today a little bit about data in financial services. My name is Mike Waldrop. I'm part of DataStax and the data architecture team. So I'll share some stories today and a little bit of insight that we've learned working with our partners and enterprises in the financial services space around data. So certainly, I think we're all quite aware of some of the pressures in financial services companies today. A lot of changing market conditions, a lot of new entrants from the technology spaces. A lot of the customers that we talk to in financial services really have transitioned to becoming more of a technology company than a bank or a financial services company. So all of these factors are leading together to require additional velocity and innovation around how to interact with customers, how to leverage data across the organization. If we take a look at the next slide, you see some of the types of scenarios that are required to truly create, we talk about the bank of tomorrow, but this idea of unlocking the value of the data. So whether it's things like Customer 360, whether it's other types of applications that are required to really leverage information about the customer, improve the customer experience, and how does data play a role in that? That's really kind of the topic that we want to describe and share some specific details around. If we take a look at the next slide, please. The experience that we have at DataStax and with our partners at Ippon is what's really required is this idea of transformational data. So by this term, what we're really talking about is gaining insights from large amounts of data, given the challenges listed here. So things like data relevance. How do I add context to my data so that my applications and experiences not only understand information like account balance, et cetera, but in the context of the customer experience. So marrying together data across multiple channels within an organization. Certainly concepts like data sovereignty. How do I get command and control of this data when it's most likely distributed? It's no longer in one single point. I have data near my customer. How do I get command and control of this data in this distributed world? We talk about accessibility, and here what we're really referring to is how easy is it to reflect that data into the applications that we need to build to connect to our customers and create an agile ability to respond to market demands quickly. Certainly scale is always important, and particularly in these types of use cases, and availability is just table stakes. downtime is not acceptable. I don't have maintenance windows any longer. I need continuous availability across the entire global network. So if you look at the next slide, we're talking about some of the types of companies that between Ippon and DataStax that we've worked with together to understand these types of problems and how to solve them. So there's very specific use cases listed here in a collection of the types of enterprises that has helped us gain this insight and approach to how we solve customer 360 problems. Even some people looking at more core banking features like loans, et cetera, and payment systems. These companies are making big changes to their technology, and those are the kinds of changes that we have been involved in and that we want to talk about. So to get into a couple of specific examples, if we take a look at the next slide, Capital One is a enterprise that we've done a lot of work with, both with Ippon and with DataStax. And really their core issue was how to take these multiple channels of data about their customers and marry them together to create a better customer experience. So certainly we're talking about data at scale. We're talking about their core systems of banking that leverage particular data functions and how we expose those. We're going to dig into this one a little deeper a little later on, but Capital One has solved a variety of use cases across their organization using this data platform that we're describing today. The next use case on the next slide is about ACI. You may be familiar with them. They process a lot of credit card transactions, so incredibly high volumes of transactional data. And for ACI, their core challenge is they're looking for clues about fraudulent transactions in real time as the customer makes the credit card swipe. So when we talk about performance requirements, what we normally first think of is, I don't want a spinning beach ball on a user application. But for ACI, it's even deeper than that, because for them, every microsecond that they can use to evaluate rules and information about that transaction to potentially identify fraud, every microsecond they can do to detect that fraud before the transaction is completed prevents these coordinated attacks from very sophisticated bad guys. So we take a look at the next use case. Banco Itaú is one of the largest banking and financial institutions in Latin America, based in Brazil. They're also one of the largest customers of IBM's mainframe products, and their entire bank has been running on the mainframe, as have most. What Itaú is starting to do is look at strategic workloads that they can migrate from their mainframe environment to a distributed modern architecture that we're describing today. We've partnered with Itaú at how we find those workloads, move them to this new modern architecture to drive these more flexible, dynamic customer experiences that they need to build. So let's talk a little more about that. If we go to the next slide, what I really want to share with you is some of the insights when we're thinking about these mainframe and legacy systems. We've been talking for many, many years about how migration from mainframe is needed and necessary and valuable, but how does one really go about that? If we go to the next slide, we can see what we have found working with a lot of these enterprises. If you really think about mainframe workloads, there's often a high predominance of these workloads that are a small section of the total transactions that I do, represent a big piece of the functionality. So it may be a small subsection of the entire transaction workload of all the applications that end up taking up a lot of MIPS and cycles. And a lot of these are just pure read only. I need a system of reference. I need multiple applications to go look at an account balance or a transaction record or a journal, and constant reading across multiple applications. So you see some examples here. They can be these journal things, authorization things, et cetera. But sometimes these are really prime targets for things that we can start to modernize against. Certainly, there will never be a big bang that says we're going to turn off our mainframe tomorrow, at least not in the foreseeable future. So it's really this pragmatic approach to how do we find the workloads that are most suited, that I can get a lot of value from, and that I can migrate and mitigate risk while I do that. If you take a look at the next slide, we've sort of developed this kind of way of thinking through this. A lot of it is what you would expect, but it's really understanding the drivers that are leading us to modernize. Is it more flexible applications? Is it around global distribution of the data? There's a lot of different drivers that get you there. And then really scrutinizing those workloads and finding the right ones to start with to drive this incremental improvement. Big bang migration off of mainframe is really a frightening task, but when we can break it down and go incrementally, we've had real success with some of our bigger enterprises here. Can we go to the next slide, please? So what is this scale out data approach? Let's just talk a little bit more about what that looks like and what that involves. So one of the key things that's important that we have found working with a number of enterprises is to come up with a data strategy that aligns with all of the constituents within the organization involved, not just the developers, not just the operators, but the developers, the operators, architects, how we're going to integrate into the environment, and of course the lines of business and what we're trying to accomplish. Getting alignment around multiple constituencies with this strategy is super important. The next slide shows a depiction of the DataStax approach to this scale-out cloud-native data platform that we're describing. So at the heart of it, at the foundational level, we have built the technology around Apache Cassandra, the largest NoSQL, most reliable infrastructure available. So people are looking to Cassandra to get the kind of performance and reliability that they expect without being locked into a particular vendor. This is the heart and soul of how we solve this problem, is built on open source Apache Cassandra. DataStax is committed to the open source movement and continuing to improve the open source Cassandra capabilities that are available. But we've added on top of that needs for our enterprise customers. To get to the trusted level, there needs to be tested capabilities, there needs to be security, additional encryption, things like that. These are requirements for any large enterprise on top of what you get out of the box with open source Apache Cassandra. And then to accelerate the efforts, we've added additional capabilities unique to different use cases. So being able to handle multiple types of data, to be able to run analytics workloads against this data, to be able to have flexible queries using an extension that we talk about, search, and even in some use cases, actually being able to interact the data through a graph approach as opposed to pure transactional queries. So DataStax is one of the leaders in innovation around graph technology, and this can be applied a lot of times to fraud detection use cases or other cases where the relationships between the data are so critical. We add on top of that the operational needs around APIs and deployment, things like Kubernetes and other ways that people are looking to deploy these technologies to deliver those experiences at the top level that drive the differentiated business outcomes our enterprises are looking for. Go to the next slide, please. So these are the capabilities from DataStax that meet that vision. So just to give you some language around the DataStax capabilities, DataStax is building this hybrid database as a service offering all around Apache Cassandra right in the middle. The way we're going to do that is with one consistent control plane that can be applied to Cassandra operations, whether they be on-prem or in any cloud provider. So a single graphical way to manage on-prem, in cloud, anytime scenario. We'll add to that some best-in-class operational tooling to manage this system for you. We want to make it so our enterprises can be as hands-off as possible in managing these complex environments. So across the top, you'll see there's a couple of ways that customers consume this capability. One of them is a preference for open source Cassandra for some use cases. So DataStax can support our enterprises that choose to use open source Cassandra for some of those use cases. For other use cases, they need some of those additional capabilities we described earlier. And that's what we call our DataStax Enterprise, soon to be called Astra Hybrid. This is for enterprises that need to self-manage this complex environment and have all of those capabilities. So this is our hybrid option. It can run on-prem, it can run in a cloud provider, but it is managed by the enterprise. And new to the market is our Astra Cloud offering. So we're quickly creating a completely as-a-service offering to meet some of these needs. So most of the enterprises we're talking to today have a mix of these three. It's not one or the other, it's always a combination. They have use cases where open source is most applicable. They have use cases where they want completely managed as a service, and then some that they want to self-manage. Can we go to the next slide, please? So this is the description, if you will, of this scale-out data platform, cloud native, that we're talking about. This business velocity we're seeing in financial services is driving the need. These differentiated business outcomes can only come with this type of platform. We talked a little bit about this legacy and mainframe migration, the strategic approach, finding the right workloads, and then scale out data requires that alignment that's there. And we believe Cassandra has been a very good fit for these. And in fact, Theo's going to take us into a little more details about how we've done this with some of our enterprises, kind of what that looks like underneath the covers. So Théo, we'll switch over to you now and get a little bit deeper.
Sounds good, Michael. And yeah, thank you for your presentation. So yeah, let's just start, with the classic introduction slide. So my name is Théo Lebrun. I'm a cloud and data architect at Ippon Technologies USA. And yeah, I've been working at Ippon for like around 5 years. And during those years, I worked on multiple assignments at different clients. In total, I worked on 3 projects that were like involving Cassandra. So yeah, and also, here's the link of my social networks. So, if you want to follow me on Twitter, on GitHub, and also my personal website. So yeah, today I'm going to talk about a project that I worked on for 5 months at Capital One, and why Capital One decided to pick DataStax. So first, let's do a quick summary about the project itself and its requirements. So again, the project is pretty straightforward and involves like 2 major components, the data store and an API. There's also like a third component that is not listed on this slide. Is basically the component that is inserting the data into the data store. The frequency is daily, and so let's just first talk about the data store itself. So the data schema, it's pretty simple. At the end it's just one table with 9 columns. The volume of data is pretty impressive, though. It's right now, like currently, they have like almost 1 billion records in this table, and like very a key point and like a key aspect to to have in mind is that this data store must be able to handle like a very big data growth, because like right now it gets like new records, like around 15 million records are being added every month. So again, you want like a data store that is able to handle a lot of records and also is able to grow through time. And about the API is pretty simple. It's just querying, like reading the data store and returning the data. Currently, there's like around 150 requests per second, so it's quite like a pretty big API that are being used by a lot of services in Capital One. And also, like the big requirements for this API is to have an average response time that is less than 200 milliseconds. Because obviously you don't want to impact all the other services around, because if your API takes too long to answer, you might like impact your other services and the whole flow will be slower. So initially, AWS RDS was picked by Capital One. I was not part of the project when they did this decision. So, you know, I don't really know the reason, but I guess it's probably for like its simplicity. And also because, you know, they were not aware of the volume of data, like they didn't know it was going to be like that big. So, you know, you can see the metrics with RDS on this slide. The main problem was that, you know, the API, the average response time of the API was like around 300 milliseconds, which is, you know, like a lot. And it was like way above the 200 milliseconds that were like required by the whole project. And also like something to note is that in just a month, the response time increased by like 100 milliseconds. So again, it was definitely like, you know, okay, RDS was not a good fit. And when Capital One switched to DataStax Enterprise, as you can see, the performance was like way better. Like I remember when we did the switch and we were checking our dashboards, we saw like, you know, that the API response time was now like around 15 milliseconds, and we're pretty happy with the result and everything. And also I put it like some metrics about the cluster just to give you like, you know, an idea of how big the cluster is. So yeah, like there is around like 500 read requests per second and around like 650 write requests per second. So again, it's a pretty big, Cassandra cluster that is able, you know, to handle those read and write requests with a big, like around 1 billion records in the table. So now I'm going to, you know, talk a little bit about the architecture. To be honest, the architecture is pretty simple and pretty straightforward. There's nothing too crazy about it. As you can see, there's like a cluster of 9 nodes. Those clusters contain 3 seed nodes. And then on top of those 3 seed nodes, you have a DNS record with a route 53. And finally, the API that is deployed on ECS communicate with the cluster through the route 53 DNS. Again, nothing too complex about the architecture. Let's talk a little bit more about, you know, the cluster characteristic itself, because I feel like that's more important and more interesting. So the version used for DataStax Enterprise is the version 6.7.6. The cluster is deployed on both East and West, so on 2 different regions, but it's only in 1 AZ. I don't know if right now, maybe now it's like like more than 1 AZ, but when I was working at the project, it was just 1 AZ. And yeah, like I said, it's 9 nodes in total, so 3 seed, 6 non-seed. And also, yeah, for the instance type of our EC2s, we decided to go for the type i3, which is, you know, a type that is designed to handle like high random IO performance. So, you know, that really like fits our need right here. You can go, so we choose like a 2x large instance type, but you can go like up to 16x, sorry. But, you know, for this project, 2x was enough and everything. And then for the storage, you have a choice, you know, between using the instance store of your EC2 or EBS. I would say it depends of your workload. It depends what kind of operation your cluster is going to do. For us, we decided to go with the instance store that was like, you know, truly fulfilling our needs. And the size of the store itself is 30 gigs. So now let's talk about the tools that we use, you know, to like deploy and maintain the whole cluster. So I'm going to talk about three big tools: Terraform, Ansible, and Datadog. So let's just start, you know, with Terraform. So if you never heard of Terraform before, Terraform is an infrastructure as code software that will, you know, help you. Sorry. Oh, I don't know. Michael was talking, but yeah, about Terraform. Like I said, it's a cloud agnostic tool. That way you can, you know, deploy your whole like cloud architecture on 2 cloud providers. So for example, AWS and Azure. The way it works is pretty simple. You know, you configure Terraform with your code, and you can like provision In our case, we're like provisioning the whole cluster, you know, with like EC2s and network instances, also configuring the DNS with Route 53. And then when everything is up and running, Terraform was creating an Ansible inventory file, you know, that contains all the IPs of your EC2s. And then we can use Ansible with this inventory in order, you know, to like do the configuration, deployment, and the cluster management. So if you never used Ansible before, it's basically a tool like Chef or Puppet. And the way it works, it just, you know, it just run your playbooks over SSH. So a playbook, what is a playbook? Is you just define, you know, your task that you want to achieve over SSH. So for example, in this project, we had like more than 15 playbooks. So, you know, a playbook will be, for example, stop a cluster, start a cluster, restart a cluster, take a snapshot, or like something like run node tool. Because, you know, if you think about it, if for some reason you need to run node tool repair on all your nodes, so for example, 9 nodes, it's, you know, it's like very manual and it's not automated. Like you don't really want to SSH to every node and then run node tool repair. Like it's just that would take too long and be like way too complicated. So with the help of Ansible, you will have a playbook that will, you know, just do the node tool repair for you. And your Ansible will just connect through SSH to all your nodes and run your node tool repair command. So again, the main key point of Terraform and Ansible is to have, you know, a very big automation and, you know, to save you a lot of time and avoid doing manual things. And also Terraform was, you know, configuring the cluster by creating the Cassandra YAML and, you know, doing things like creating the key space, the users, and the tables. So that's kind of all, you know, for the whole like deployment and maintenance of the cluster with the Terraform and Ansible. But also we were using a tool, Datadog, for all the monitoring. So if you never use Datadog, I really recommend using that tool because it is, you know, pretty useful, pretty user-friendly, and pretty easy to pick up. The way it works is basically you install on all your EC2's instances, you install a Datadog agent that, you know, will retrieve all the metrics and then send them to Datadog. So in our case, we use like 2 different configurations. We use the Cassandra configuration that basically get the logs and get the metrics using JMX. And we also use another configuration, which is the node tool one that, you know, will give you health of your nodes and give you metrics about your key space. So in our case, we created like 2 dashboards for Datadog. We created a cluster monitoring dashboard with, you know, that gives you the status of your node and the read and write request count. And also for the API, we created another dashboard that gives you, you know, the total amount of requests for the API. And then the key metric again here was the average response time, you know, in order to stay under the 200 milliseconds. So let's take a look at those dashboards. I made like, you know, 2 screenshots for both the cluster monitoring and the API monitoring. Again, it's just a screenshot. Like the dashboard itself is bigger, but, you know, I decided to only like screenshot the important parts. So yeah, for the cluster monitoring, you can see here on the top left, you have the node status, you know, that gives you like if your nodes are like up and running. So I think right now it's not a 9 node cluster anymore. It's a 12 cluster. So that's why there's like way more than 9 nodes. And also you have like very important metrics, like, you know, the number of drop message and the read and write request counts, and also the same things for the latencies, you know, the read and write latencies are like pretty useful in order to know that your cluster is, you know, healthy. And then on the API, you have the metrics for the API. Again, there's nothing too crazy about this dashboard. It's just, you know, the average response time that again is the key metrics here. And then the number of request count per second. So another good thing about Datadog is that you can, you know, set up alerts in order to like notify you if there's like any issues with your dashboard. So for example, you could like set up an alert, you know, on the node status, like if a node goes down, Datadog will send you an email or like, let's say, a message on Slack. Or you can also set up, like alerts, like with thresholds. So for example, if the write latency goes too high, or same thing for the read latency, and the same thing for the response time. So again, I really recommend Datadog for the whole monitoring part. And a good thing to know is the cluster monitoring dashboard is actually like a default one provided by Cassandra. So, you don't really have to build it from scratch. You can just copy paste it, and it is like a pretty useful dashboard. And then of course you can add like other widgets in order to make it more complete for your cluster.
Yeah, Theo, if you don't mind, I'll just add in real quick. I think that that idea of a mature sort of monitoring and DevOps pipeline is something that we see over and over again. Once, particularly as an enterprise kind of takes on this data platform after a project or two, trying to get all of this put together is so critical. And at Cap One now, I think you mentioned it already, but their ability to spin up new projects because all of this infrastructure in place has really accelerated. So now the time that it takes to get going on a new project with all of the pieces and parts together, and there's additional obviously options and availability, but being able to automate the deployment, the monitoring on all of that is a super critical part of this. And that's where the expertise of folks like Theo and his team and folks from DataStax can help enterprises get up and going with all of the required infrastructure to do this.
Yeah, that is correct. Let's keep going with, let's talk a little bit about the cluster rehydration. So let me just first explain what is the cluster rehydration, because it seems like a little bit like confusing at first. So the idea is that all our AMIs, they needs to be updated every 60 days. So in order to do that, you basically need to spin up new EC2s with the new AMIs. You cannot replace the existing EC2s with the new AMIs. So the big challenge here was to, okay, we need to create new EC2s with the new AMIs. So that means we need to create basically a new cluster. And then we need to transfer all the data from the current cluster to the new one. And then, make sure that everything was transferred and everything is working fine. And then we can just update the Route 53 DNS and to have, have our APIs connect to the new cluster. And then we can just remove and shut down the previous cluster, I mean, the old cluster. So in order to do that, we leverage a lot Ansible, and especially with playbooks. Obviously, the first time we did it was a little bit confusing. It was the first time we were doing it, and we didn't really know what to do. But then after that, we created like playbooks in order to make our life easier. And yeah, just to give you a small idea of the data replication, it was taking about 10 hours to complete. So, because it kind of depends on your network and other factors. But like I say, it was a lot of data, and creating this new cluster and then connecting from the previous one was just taking there's no really way to speed up this process, unfortunately. But the good thing, it was just around 10 hours, so it was nothing too crazy. Another important topic that we had to do is obviously backup and snapshots. So the reason we had to do manual snapshots is because we didn't use EBS, because with EBS, you can have snapshots done automatically with AWS. But yeah, since we were using the instance store, we had to manually do those snapshots and backups. But again, with Ansible, it was pretty easy to achieve. There's a small diagram about how it works, but it was just a playbook that was letting Ansible do a cleanup, then create the snapshots, and then upload everything to S3, and finally clear and remove the snapshots on locally on the EC2s. I think the frequency was daily, but yeah, again with Ansible and the playbooks, we didn't do it that manually, obviously. So finally, I'm going to talk about resources that were pretty useful during this journey. The first one, it's called NoSQL Bench, which is basically, you know, a stress test made by DataStax that will, you know, help you because, you know, when you create like a new cluster and you don't really have data inside, and, you know, you kind of want to know if, you know, your network is good, if your cluster is actually really like up and running and will be able to handle like, you know, an heavy load. So in order to do that, you know, I recommend using this tool, you know, to run stress tests on your cluster and make sure that, you know, your cluster will be able to handle like a very high traffic. Another resource that was pretty useful is, and so you remember I talked about like, what do you have to pick between EBS and Instant Store? So we have a blog on our like Ippon Technologies website. So, you know, if you're curious about that, feel free to read it. But basically, like I say, it depends, you know, on your workload. So again, if you don't know what to use, I recommend reading this blog. And finally, the last resource that was, you know, pretty useful, it's called the last pickle. So actually, fun fact, the last pickle is now part of DataStax since March 2020. And it is basically, you know, a big like blog platform where, you know, you have like a multiple of blogs about like different topics with Cassandra. So for example, one that I like is a blog about like, you know, 14 things to do when you set up a brand new Cassandra cluster. Because, you know, sometimes you set up a cluster, you do things, you had data, and then you realize, oh, I should have done that, and now it's going to take longer to do. So again, I recommend reading this blog. They will, you know, tell you things you can do before setting up a new cluster in order, you know, to save time later. They also have like a stress tool. Again, I think the NoSQL Bench is better, so I recommend using that instead. And finally, the last resource is a blog about the encryption. So with Cassandra, you have two different kinds of encryption. You have the node-to-node encryption, so the inter-node encryption, and then you have the client-to-node encryption. So, you know, setting up encryption for your cluster could be a bit confusing, especially if you never worked with, you know, Java Key Store or Java Trust Store, because, you know, it's like complex and you need a certificate to sign, you know, files and things like that. So I recommend, you know, reading this blog that will, you know, tell you more about that and will really explain step by step how to achieve that. Okay, so now I'm just gonna let Nick talk a little bit more about Ippon USA and what we do.
Thanks, Théo, and thanks again, Mike, as well for this presentation. So yeah, quick overview on Ippon Technologies USA for those that aren't familiar. We are a consulting firm, originally started in France and still headquartered there. And we started in the US in 2014. Up and down the East Coast, we're headquartered in Richmond, Virginia, with additional offices in Washington, DC and New York City. So as you can see here, our specialty is really anything from A to Z when it comes to your IT needs. You know, we talk about how we really like to accelerate. We always use that word, accelerate your digital roadmap and from discovery to delivery. So as you can see, we do anything from discovery sprints to assessments to strategy overviews, and then actually put the pieces in place to get the development in place. And even as you can see on the back to step 3 is DevOps, cloud, data, and run. So really from start to finish, we like to step in and be that resource. As Théo mentioned, we do have a blog that we do maintain pretty frequently. In fact, we've had, I think, 5 or 6 entries in the past 5 or 6 days, in fact. And then our website, as you can see, where you'll see a lot more information about what we offer, white papers especially, and more about the history of Ippon and sort of what we do, both in terms of you know, our IT solutions and really for the community as well. And then finally, some of you actually may be familiar with JHipster. It is an open source tool, actually, as a software generator that really does accelerate your time to market for even the most simple web applications, which implements Java Spring Boot on the back end, and your choice of Angular, React, and Vue on the front end. And then it really is, the best part about it is it's out of box compatibility with all the cloud providers and whatnot. So seamless setup. There's plenty of contributors as well across the globe. And so we're constantly updating it with new features to make it more friendly for all. So I do encourage you to check that out as well.
Yeah, Mike, I don't know if you want to say a few words about this
Sure.
slide.
Yeah, I just wanted to offer, if some of this looks interesting, you really want to get your hands on Cassandra and learn it. We are starting a session DataStax is offering starting next week for free to get training on Cassandra. It will all be virtual. You can see some details here, but and we can share with you, but really great way for people to get up to speed. One of the big things that DataStax is focused on is just helping the broader Cassandra community get up to speed, and more developers that can learn this technology and how to use it. So lots of opportunities to learn and develop. There are Cassandra certifications that can happen, and there are ways to do that. So you may see some follow-up from us about this, but if you're interested, this is the URL, and reach out to us. We can help you. There's all kinds of other enablement pieces, but we're finding a lot of developers that are hungry to learn more and more. So we're providing new and exciting ways to get that knowledge. So this is out there. So I don't know if folks on the line have questions that you want to put in the chat window. We can certainly, Nick, I think that's where we are at this point. Is that right?
Yeah. So again, yeah, anybody with questions, feel free to put them in the chat. We'll pause for another minute I know in case people need time to type those in. So yeah, feel free to get those in now, and we'll be here to answer.
I think while we're waiting, I'll just offer my last sort of summation here. I think what you've hopefully seen is there are capabilities to solve these complex problems. It does require a slightly new way of thinking. If you're not familiar with Cassandra, there's a lot of expertise that you can leverage to get you there. These problems have been solved a few times now. There are repeated patterns that we can share and hopefully help folks getting started on this journey. And the journey may start with a little bit of learning about Cassandra. It can start with more detailed conversations about use cases, and we're always happy to engage in those in any number of ways, from just developer to developer to, hey, what does this idea look like, or a more structured conversation if that's needed. So appreciate you guys joining today. Hopefully this has been helpful.
And I did see a question, will this recording be shared? I think the plan is yes, at least for on the Ippon side. I believe we will be getting it published on our Ippon YouTube channel. I think that is the plan up front. Mike, I'm not sure, do you know if DataStax has a plan to publish this as well?
Yeah, we'll definitely make it available. Absolutely.
Excellent. So yeah, there'll be multiple avenues for people to see it. And then, yeah, of course you can, if you know of colleagues that unfortunately were not able to make it, definitely feel free to share. And I think the best part is you'll be able to share and see the resources at the end again. So yep, they will be available. Any last minute questions? All right, then I think that's probably a good place to come to an end. So thanks again, everyone, for joining. Obviously it's a very, very hot topic, as we'll call it, in terms of financial services and really making sure that your data is effective and all the systems in place are really essentially keeping up to speed and keeping up to your constantly evolving needs. So Mike, Théo, did you have any parting thoughts before we closed out?
Nope, I have nothing.
No, that's good. Thanks everyone for participating and joining today. Hopefully it was helpful.
All right, everyone, take care and thanks again.